life finds a way, even in the harshest environments. Floating 350 kilometers above the Earth's surface, astronauts aboard the Soviet space station Mir made a shocking discovery. A once clear porthole was now coated in a green and black, web-like substance. Soon, these strange growths were found throughout the station, spreading over air conditioners and corroding control panels, endangering both the station's systems and the astronauts' lives. The culprits: several species of fungi, originating from Earth, that had managed to survive the trip to space. Even more impressively, they adapted to the station's microgravity and radiation-heavy environment. Despite the threat, the astronauts successfully contained the fungi, and Mir remained in orbit for another 13 years. Over time, scientists realized fungi could actually help, not harm, space travel. These resilient, often underestimated organisms may play a key role in humanity's future on other planets. Outside Earth's protective magnetic field, most life forms need substantial shielding from the DNA-damaging effects of cosmic radiation. But many fungi produce a special type of melanin that not only absorbs radiation but also, in some cases, uses it as a source of energy to fuel their growth. Even if high radiation levels damage their DNA, fungi possess robust repair mechanisms that leap into action, fixing any damaged sequences. But radiation isn't the only cosmic threat fungi can withstand. Their tough spores have thick cell walls that protect them from extreme temperatures, making them well suited for space. So, how might we harness fungi for space exploration? One major challenge of settling on other planets is securing the materials needed to construct habitats. There are two typical solutions: sending supplies from Earth or using what's already available on other planets. However, sending materials into space is costly, around $10,000 per kilogram. And using local materials, like regolith, the dust and rock covering planetary surfaces, would require heavy, energy-draining machinery to process it into something usable. Enter fungi. Most fungi grow using hair-like root structures called mycelia. As these structures expand, they can bind to nearby materials, including regolith, forming a dense, interwoven network. This natural material is surprisingly durable, providing thermal insulation and protection from radiation. NASA's Innovative Advanced Concepts program is exploring ways to use fungi to grow homes on other planets. The concept involves sending lightweight, flexible bags, seeded with dehydrated spores to space. Once they arrive, rovers would gather water and regolith to activate the spores. Alternatively, the bags could be pre-seeded with lightweight binding materials like wood chips. Alongside the fungi, cyanobacteria would be included to provide nutrients and convert sunlight into oxygen for the habitat. As the mycelia grow, they would fill the bags, forming the walls, roof, and even furniture for the structure. Maintenance would be simple: cracks or damage could be reseeded and regrown. Additionally, scientists are working on engineering cyanobacteria to glow when oxygen or pressure levels dip, acting as an early warning system for astronauts. Of course, there's still significant work to be done before these fungal habitats are ready for space travel. In the meantime, researchers are refining these techniques by building sustainable, carbon-negative fungal structures here on Earth. And fungi could do more than just build homes. Since soil suitable for plant growth is scarce in space, fungi could release enzymes that break down carbon-rich asteroids, creating soil for crops. They could also be engineered to extract valuable metals like aluminium and iron, allowing space colonies to source these materials locally. From their humble beginnings as a hazard on the Mir space station, fungi have evolved into potential partners in space exploration, and they will undoubtedly continue to break the mold. For further exploration, check out studies on how fungi can thrive in extreme conditions and their potential applications in space colonization. You can dive deeper into NASA's research through their Innovative Advanced Concepts (NIAC) program, and for those curious about space microbiology, reading materials like The Microbial World of the Space Station could offer fascinating insights.